Good morning. I want to make a claim that will sound obvious, but is rarely treated as a design requirement. Behind every system that is easy to scale and evolve is an architecture built on clarity, not complexity. Yet we work in a culture where architecture is often treated like a stack of buzzwords. If we can name enough technologies and patterns, we assume we have made progress. Today I want to replace that with something you can actually use. 3 filters that help you design intelligent architecture without leaning on buzzwords. Then we will apply them to 4 decisions you are making constantly: boundaries, data, cloud, and scaling. If you leave with nothing else, leave with the filters. They are how you stop shipping complexity as your default output. We have all seen this moment. Something breaks, and the room immediately reaches for blame. It's your fault. Did you even test this? Now, sometimes there are real quality issues, but very often that blame reflex is a symptom of something else. The system is too complex to explain, so people replace understanding with accusation. If nobody can localize the problem, the easiest story is that a person failed. That is why architecture matters. Architecture is not an ivory tower activity. It determines whether an incident becomes a calm diagnosis or a social meltdown. Simplicity is not aesthetic. Simplicity is operational stability. This is the trend I want you to notice. We are shipping more complexity than capability. More services, more layers, more frameworks, more dependencies, more hops, more workflow engines, more coordination, and then we act surprised when changes take longer. Deployments become rituals. Onboarding takes months. Incidents turn into detective work. The hidden cost is cognitive load. The tax you pay is not just a runtime cost. It is the cost of understanding under pressure. So the question becomes, how do we build architecture that remains understandable under stress? Let me be explicit. Kubernetes, CQRS, event streaming, service meshes, and these are great tools, but they are terrible defaults. The problem is not that these tools exist. The problem is premature stacking and globalizing complexity to solve localized problems. You can build world-class systems with these tools. You can also build a distributed debugging machine. So today is not anti-tool. Today is anti-default. This is the line I want you to remember. Clarity is an availability feature. Availability is not just it responds to pings. Availability includes, can your team detect a problem, localize it, change safely, and validate quickly? If the system is up but nobody can confidently modify it, it is not resilient. It is brittle and expensive. So we are going to treat clarity as a first-class architecture goal. Here is the plan. First 3 filters. 1, the 2 AM test. 2, the half rule. 3, primary path first. Then we apply them to 4 decision areas: boundaries, data, cloud, scaling. This is intentionally practical. You should be able to take this back to your team and use it without needing permission. This is where architecture shows up. Not in the calm meeting room, not in the diagramming session. Architecture shows up when someone is tired, under pressure, missing context, and expected to fix something fast. If your system punishes them, it is because the architecture made diagnosis and change too difficult. So filter number 1 is built for this moment. The 2 AM test is a rubric with 4 questions. First, detect. Do we know something is wrong quickly? This is not about having dashboards. It is about having signals that map to user impact. And if detection is slow, everything downstream gets worse. Customer support noise, war rooms, and guesswork. Architecturally, detection improves when You know your critical user journeys. You measure what matters. You have clear health indicators tied to outcomes. If you want systems that scale, start by making problems visible fast. Second, localize. Can we pinpoint where and why? This is where unclear architectures collapse. If you cannot localize, you cannot reason. If you cannot reason, you cannot change safely. Localization comes from clear boundaries and seams. Ownership that is obvious. Traceability across components. Minimizing mystery coupling. Your goal is not perfect architecture. Your goal is a fast, reliable diagnosis by normal humans. Third, change. Can we modify with confidence? Confidence comes from the ability to make a change without triggering a chain reaction. That means stable interfaces, explicit dependencies, clear blast radius, change paths that do not require 5 teams to coordinate. A system that cannot be changed safely will eventually stop being changed. And then the business adapts around the software instead of the software adapting around the business. Fourth, validate. Can we prove it is fixed? Validation is what prevents we think it's fixed from becoming it broke again. This is about fast feedback, tests where they matter, deployment safety, and operational confirmation that matches the original symptom. If you cannot validate quickly, you will ship uncertainty. Uncertainty is how incidents repeat. Here are common choices that fail the test even when they look modern. Hidden coupling. Everything depends on everything. Cross-service workflows with unclear ownership. Distributed complexity before you need distribution. Shared everything libraries that turn one fix into coordinated release work. Telemetry that produces volume but does not answer. If your team routinely asks, "Who owns this?" during an incident, that is not a people problem. That is an architecture problem. What passes tends to look boring, and that is a compliment. Explicit boundaries, even inside one deployable unit. Stable interfaces and clear contracts. Dependency direction you can explain without a whiteboard. Clear ownership, a workflow that helps people do the right thing by default. If your architecture makes localization easy, it buys you time. And time is what you never have at 2 a.m. Now instrumentation. You do not need more logs. You need more signal. 3 must-haves. 1. A correlation ID or trace ID that follows a request end to end. 2. Domain-level logs or events that state meaningful business facts, not just technical trivia. 3. High-level indicators tied to impact. Latency, error rate, saturation. Instrumentation exists to answer 2 questions quickly. What is broken and where should we look first? The half rule is an antidote to future-proofing theater. Build half of what you think you need. Treat the rest as a hypothesis. This does not mean rushing. It means earning complexity with constraints. The more uncertain the future, the more valuable simplicity is today. Let me underline it. Half rule is not anti-architecture. It is pro-evidence. When teams overbuild early, they spend complexity budget on imaginary problems. Then, when real problems show up, they have no budget left. So we reduce the scope intentionally. We build the simplest version that can survive reality. Then we evolve. Every abstraction spends budget, cognition, operations, latency, tooling, coordination. If you spend that budget everywhere, you hit the wall where changes become slow, risky, and political. Half rule asks, what can we delete, postpone, or localize without reducing core capability? Here are subtraction tactics that work in real systems. First, kill internal frameworks that add ceremony but not capability. If the framework is mostly a wrapper around the platform, it is a tax. Second, collapse service count when boundaries are unclear. If you cannot explain ownership and contracts, splitting did not create clarity. It created coordination. Third, replace distributed orchestration with simpler sequencing when scale does not justify distribution. Distribution is powerful when earned. It is costly when premature. The goal is fewer moving parts per unit of capability. Important, subtraction is not a religion. Do not subtract when constraints truly require complexity. Regulatory boundaries. Isolation for failure domains. True independent scaling needs. Team autonomy with proven ownership and contracts. Simplicity. First is not small at all costs. It is justified complexity only. Primary path. First means make the 80% path boring, resilient, and fast to understand. Most teams accidentally do the reverse. They architect edge cases first, and then the primary path becomes a maze. You are allowed to make the primary path boring. Boring is not simplistic. Boring is disciplined. If the primary path is clear, you get faster development, fewer surprises, safer changes, easier onboarding. If the primary path is not boring, everything else becomes harder. Observability, security, performance, and debugging. Edge cases are real. The fix is not ignoring them. The fix is to contain them. Edge cases belong behind seams, policies, adapters, workflow steps, specialized handlers. Do not smear edge case logic across the core model or every service. That is how systems become hard to reason about. Primary path first is how you keep the system teachable. Now we apply the filters to the decisions that create most architecture pain. Same 3 filters, 4 decision areas. The point is to stop debating patterns in the abstract and start evaluating choices through clarity, operability, and changeability. Let's go one by one. Decision area 1. Boundaries. Boundaries exist to improve localization and safe change. If your boundaries are unclear, everything becomes harder. Ownership, deployments, debugging, scaling, and compliance. So here is the most important boundary point in the talk. Microservices are a deployment choice, not a design starting point. If you cannot define boundaries clearly inside a single code base, splitting into multiple deployables will not create clarity. It will create more hops, more coordination, and more failure modes. Start with modules. Earn microservices with constraints. A modular monolith is not one big ball of mud with a nicer name. It means explicit module APIs, internal encapsulation, clear dependency direction, separate data ownership when feasible. This is the fastest path to better localization without paying distributed systems tax early. It also aligns perfectly to the 2AM test. It makes localize and change dramatically safer. Microservices make sense when you have evidence. Independent scaling needs, independent release cadence, strong ownership, clear domain boundaries, operational maturity. If those are not true, microservices often turn into distributed guessing. Half rule applies here. Start simpler, measure constraints, then earn separation. Decision area 2. Data and CQRS scope. CQRS is a common source of accidental complexity because it is easy to make it global. So we apply half rule and primary path first. CQRS is powerful when localized and harmful when it becomes an ideology. When CQRS becomes global, you duplicate models everywhere. Debugging gets harder. Reads become inconsistent in ways nobody can explain under pressure. CQRS is a scalpel, not a blanket. Localize it to hotspots. Here is the default that works for most systems. Single model. Simple read optimizations. Cache where proven. Evolve. Targeted read models only for the hottest queries. Projections only where they pay for themselves. This is half rule applied to data. Earn complexity where it returns value. If you introduce projections or async reads, you must answer this clearly. Where are we strong? Where are we eventually? Who owns reconciliation? If you cannot explain your consistency boundary, your system will surprise you, and surprises are what incidents are made of. Decision Area 3, Cloud. Cloud gives you leverage. It also gives you more ways to create hop-by-hop complexity early. So we apply the 2AM test and the half rule. Use the cloud to remove toil, not to multiply moving parts. Cloud should reduce operational burden. If your architecture adds services faster than it adds capability, you are building a distributed debugging problem. Managed services are excellent. They are also not free. Each added component can add latency hops, IAM complexity, operational surface area, vendor coupling. At 2 a.m., every hop becomes a tax you must pay immediately. Here is a sane default. Application, database. Queue when async is justified. Cache when you have proven hotspots. Observability as a first-class capability. Add services only when a constraint forces it. That is half rule applied to the cloud. Decision Area 4, Scaling. Scaling conversations often jump straight to decomposition, but the best scaling work is usually earlier and simpler. My recommended order: queries and indexes, then caching, then batching, then async where it helps, then partitioning, then distributed sprawl. This order reduces hops, reduces failure modes, and makes the system easier to localize. It also tends to be cheaper. We have all seen this. The team decomposes to scale, and suddenly more hops, more partial failures, more pipelines, more coordination, slower delivery. Decomposition can be right, but decomposition as a first move is often how teams manufacture complexity. Ask, what is the constraint specifically? What is the simplest move that addresses it? Let's close by turning this into a playbook. The simplicity code is 3 filters. 2 AM test, detect, localize, change, validate. Half rule, reduce scope, earn complexity. Primary path, first, keep the core boring, contain edge cases. If you apply these consistently, you will make better architecture decisions without needing a reorg or a rewrite. Here is a 1-week reset you can run on a single workflow. 1. Run the 2 AM test on one workflow. 2. Delete one abstraction. 3. Remove one hop, network, service, or tooling. 4. Simplify one deployment path. 5. Reduce one global pattern to a local one. 6. Add one high signal metric or log. 7. Write one ADR documenting a subtraction decision. If you do this once, you will feel the difference. If you do it quarterly, you change the culture. If this resonates, the book expands the practical side. More case studies, checklists, and decision trees. Not to turn architecture into a debate club, but to give teams repeatable habits that keep systems understandable over time. How do software developers say thank you? With a heartfelt commit. Thank you for watching.